We have learned 4 types of colligative properties. First one, RLVP, that is relative lowering in vapor pressure. Delta P upon P naught A equals to XB. Delta P is the lowering in vapor pressure. P naught A is the vapor pressure of pure component A and equal to XB. XB is the mole fraction of B component, means solute. Second colligative property, elevation in boiling point, delta TB equals to M multiplied by KB. M is the molality. Third colligative property one, delta TF, that is depression in freezing point, equals to MKF. M again molality. Fourth colligative property one, osmotic pressure pi equals to CRT. C is the molar concentration of the solute multiplied by RT. Okay. These colligative properties formulas can be used for those type of solute which do not undergo association or dissociation after dissolving in solvent. Means if the solute do not undergo dissociation, or association means not dissociate into smaller particle, not associate to form a bigger particle, then for that type of solute we can use all the 4 colligative properties formula. Means like sugar, urea, glucose, these type of solute. So these type of solute, glucose, urea and sugar, these will not undergo dissociation, or association means will not dissociate into smaller particle after dissolving in the solvent, not associate, not combine together to form a bigger particle after dissolving in the solvent. So for these type of solute we can use these formulas for the colligative properties. But if suppose any solute undergo dissociation or association after dissolving in the solvent, then we have to make some correction in the colligative property formula. For that we should understand Vant-Hoff factor. Vant-Hoff factor is represented by the I. For that we must know, as we know that the colligative property is directly proportional to quantity of solute. We have learned this. Suppose we have taken the 2 containers. In one container we have dissolved 1 mole of sugar, and in another container we have dissolved 1 mole of NaCl. 1 mole of NaCl. The 1 mole of sugar remain as it is after dissolving in the water. Means sugar particle will not associate or dissociate. Their quantity remains same, 1 mole only. But NaCl, what will happen to NaCl? After dissolving in the water or the solvent, NaCl will dissociate into Na positive and Cl negative. Here we can see dissociation. When we dissolve 1 mole of NaCl in the water, it dissociates into 1 mole of Na plus and 1 mole of Cl negative. Suppose we are taking the time 0, means just we have dissolved. Okay. So how many moles of NaCl we have just dissolved? 1 mole. So at the time of 0, means we have just dissolved. Na positive and Cl negative will not form initially. So their quantity will remain 0, 0. But at the time t, means after some time, what will happen? The 1 mole of NaCl completely dissociate into Na positive and Cl negative. Here the NaCl now become 0 because NaCl has been dissociated into Na positive and Cl negative. So its quantity becomes 0. And how many moles of Na positive form then? 1 mole. And Cl negative will form 1 mole. So we were thinking that we have dissolved how many moles of NaCl? 1 mole. But after dissolving, how many number of moles we are observing? 1 plus 1. 1 mole of Na and 1 mole of Cl negative. Means the total number of moles of NaCl or the quantity of NaCl has increased after dissolving in a solvent because it undergo dissociation. It has dissociated. So it will form 2 moles of Na positive and Cl negative. So the theoretical value which we were thinking that we have dissolved is 1. This is the theoretical value. And observed value is 2. Means total number of moles. 1 plus 1. Now the formula for the Vant-Hoff factor. Vant-Hoff factor formula is observed colligative property upon theoretical colligative property. Observed colligative property means total number of moles after dissolving. Means after when we have dissolved the NaCl or any solute in the solvent, then how many number of moles has been formed. And theoretical means before that how many moles we have dissolved. This is the theoretical and this is what observed. Means we are thinking that we have dissolved. How many moles of NaCl we have dissolved? 1 mole. So what is the formula for the I? observed colligative property upon theoretical colligative property. So here we can see I value equals to how many number of moles of NaCl has been formed now? Total number of moles. 1 plus 1. What? 2. Upon theoretical colligative property, theoretically how many number of moles we have dissolved? Only 1. So theoretically 1. So 2 by 1 value is 2. So what is the answer of Vant factor for the NaCl? 2. Okay. Then we can form this table to show the different the effect of this dissociation of the solute on the different property. Dissociation. For the dissociation, I value will be greater than 1. Always. Why? Because observed value will always be more than the theoretical value. Because in the dissociation, the solute will dissociate and will form more number of moles. So observed value will definitely more than the theoretical value. So always I value will be greater than 1 for the dissociation. Quantity of solute, we have seen that we have dissolved 1 mole only. And how many it has formed? 2 moles. So quantity has increased. So quantity will increase. So in the dissociation process, the quantity of solute will always increase. Colligative properties, what will be the effect of dissociation on the colligative property? We have seen that colligative property is directly proportional to the quantity of solute. So if the quantity of the solute is increasing, then definitely the colligative property will also increase. So in the dissociation, I value will be more than 1. Quantity of solute will increase. Colligative property will also increase. But now the solute molecular mass. We have dissolved the 1 mole of NaCl and it has dissociated into smaller particle. So when a bigger particle is dissociated into smaller particle, then obviously their molar mass will decrease because it has dissociated into smaller particle. So solute molecular mass or the molar mass will decrease. Quantity increase, number of moles increases, but their molar mass has decreased. So molar mass will decrease. Now we see in the another process association. What will be the effect on all these properties? In the association, suppose we are taking the example of acetic acid. We have taken the 2 moles of acetic acid and we have dissolved it in the benzene. On dissolving in the benzene, acetic acid, the 2 moles of acetic acid will undergo dimerization. Dimerization means the 2 moles of acetic acid will combine together to form a 1 bigger molecule. Here we can see after bracket we have written the 2 in the subscript here. So what is the meaning of this? Here we have the 2 acetic acid molecule separate condition. Here the 2 acetic acid molecule has been combined. So here in the association, acetic acid when dissolved in the benzene, 2 acetic acid molecule or the mole will combine together to form a 1 big molecule and it is known as dimer. And this process is called dimerization because the two moles of acetic acid are combining together. So initially we have taken the 2 moles of acetic acid. Theoretical value is 2 moles. And observed value means after dissolving in the solvent, how many of number of moles has been formed? 1 only. Because the 2 moles has been combined together to form 1 mole. Here it is 1 mole. So acetic acid, how many number of moles of acetic acid molecule are there now? Observed value is 1. Then I value observed upon theoretical. So what is the observed value here? 1. And theoretical value is 2. So 1 by 2 is less than 1. So for the association, I value will be less than 1. Because number of moles of the solute will decrease. Because they have combined together. So when the molecule will combine together, then their number of molecule will definitely decrease. So I value will be less than 1. Here the quantity of solute, as we have seen that we have dissolved 2 moles and has formed only 1 mole. So quantity has decreased. So quantity will decrease. Colligative property, again it is directly proportional to the quantity of solute. So as the quantity of solute is decreasing, then the colligative property value will also decrease. Solute molar mass. The smaller molecule when combined together, they will form a bigger molecule. Then definitely their molar mass will increase. So here in the association, I value will be less than 1. Quantity, we have dissolved 2 mole and it has formed only 1 mole. So quantity will decrease. Colligative property is directly proportional to quantity of solute. So colligative property will also decrease. And solute molecular mass, because it has formed the bigger molecule, so solute molar mass will increase. So you have seen all this. Now, I formula we have seen that the observed colligative property divided by the theoretical colligative property. Here we can see the one relationship. Here in the dissociation, if the quantity of solute is increasing, then the molecular mass is decreasing. Here in the association, quantity of solute is decreasing, then the molar mass is increasing, means both are inversely proportional to each other. You can see in the colligative property also, if the colligative property increases, then molar mass will decrease. Colligative property decrease, then the molar mass will increase, means both are inversely proportional to each other. So here we can see in this formula, I value is observed colligative property upon theoretical colligative property in terms of colligative property. But if we want to write this formula of I in terms of molar mass, then what will be the formula? As we know that the colligative property is inversely proportional of molar mass, and here we have written I equals to observed colligative property upon theoretical colligative property. Then, and molar mass is inversely proportional of colligative property. Then I formula will be theoretical molar mass upon observed molar mass, because colligative property is inversely proportional of molar mass. Then what will be the formula of I? Theoretical molar mass upon observed molar mass. So you just remember this difference. If we are writing the formula of I in terms of colligative property, then observed upon theoretical colligative property formula will be there. And if we are writing the formula of I in terms of molar mass, then theoretical upon observed. So this difference you should know, okay, in the colligative property and molar mass. Now, when we found the value of I, then we have to make the correction in colligative properties formula. Because as we have seen, these colligative property formulas cannot be applied for those type of solution in which the solute undergoing dissociation or association. So we have to make some correction. So first of all, we have to find the value of I, and after finding out the value of I, we have to multiply these formulas of all the colligative properties. We have seen these colligative formulas, 4 formulas here. All these colligative properties formula will be multiplied by the I, Vant-Hoff factor. Okay, then first colligative property formula become RLVP equals to I multiplied by XB. Second formula is delta TB, that is elevation in boiling point, I multiplied by KBM. Third, delta TF equals to I KFM. Fourth, pi equals to I CRT. So you should know if the solute is undergoing association or dissociation, means it will dissociate or associate after dissolving the solvent, then we have to multiply all the colligative properties formula with the I. Okay, Vant-Hoff factor. So first of all, we have to find out the value of I, Vant-Hoff factor, and then we have to multiply this colligative formula by the I. Now we can observe, we have 3 observations. First observation, if the solute do not undergo dissociation or association, means not associate or dissociate, then I value will be equal to 1, because observed value and theoretical values both will be equal to each other. Then I value will be equal to 1. If solute undergo dissociation, then I value will be more than 1, because observed value will be more than theoretical value. And if the solute undergo association, then I value will be less than 1. So you have to remember these 3 observations.